Welcome back, everyone. So today we're just going to skip right past the usual what is programming intro because you're past that. Our mission today is to really extract the core building blocks, things that make or break a developer.
Exactly. Because weak fundamentals mean you're always going to be playing catch up. But if you get these fundamentals right, you can learn pretty much any new technology fast.
So what's the biggest mistake you see people making right at the start?
Oh, it's definitely what I call language hopping. They'll jump between Python and JavaScript or chase the latest hot framework. They copy-paste code without really getting it.
Right.
And the core truth they're missing is, well, it's simple. Programming languages are just tools. Their
Right.
syntax, they change all the time. The logic underneath, that never changes.
Okay, let's unpack that logic. Where do we even begin, I guess, with how a computer handles information in the first place?
You got it. And that brings us to the first pillar, variables and data types. And look, most people know a string is text, an integer is a number. But that's surface level.
So what's the deeper insight there?
The real insight is understanding why you choose one over the other. It's not just about what it is, it's about memory. Choosing a float over an integer, for instance. That's about efficiency and critically preventing weird bugs later on. Mastering this means you're starting to think like the machine.
Right, so we know how to store data. The next step has to be, well, making decisions with it, right? Creating rules.
Precisely. And for that, you need operators and conditionals. Think about comparison operators, greater than, less than signs. You're basically just asking the machine a question. Is this user's age greater than 18? The answer is always just true or false.
And that answer then feeds into the if-else block.
Exactly. That's the conditional statement. That simple if-else logic is the foundation for everything from a simple login check to, I don't know, a complex payment system.
Now, we've got our data and we've got our decisions. But if we have to write a separate line of code for every single item we check, that sounds incredibly inefficient.
It would be. And that's why we have the tools for automation. Loops and functions. A loop, a for loop, or a while loop, is just a way to solve the repetition problem. You don't write 10,000 lines of code to process a list. You write maybe 3 lines inside a loop.
And functions, how do they fit in?
Functions solve the organization problem.
Yeah.
You take a complex piece of logic, you wrap it up, give it a name, and then you can just call that name whenever you need it. It's the ultimate write once, use everywhere principle. Keeps your code from becoming a total mess.
That brings up a huge question we always hear. If you're starting out, which language should you pick? People always ask, what's the best language? But maybe that's the wrong way to think about it.
It is. The smart question isn't which is best, it's which language will help me understand this logic most clearly.
So what are the options there?
Well, our sources really point to 3 main paths. You've got Python, which is fantastic for beginners. Super simple syntax, and it's huge in AI and data science. Then there's JavaScript. If you're doing anything on the web, it's not optional. You just have to know it.
Okay, but then there's the other one, C language. It's older, it's harder. Why would anyone start there if Python is so much easier?
That's a great question. Because C forces you to understand the machine. It doesn't hold your hand. You have to think about memory, about performance. It's a much steeper climb, yeah, but the foundation you build is rock solid.
So no matter which language you pick, how do you practice this stuff effectively?
The key is to avoid what I call tutorial addiction. You know that cycle of watching a tutorial, feeling like you get it, and then forgetting it all a day later.
What absolutely the dreaded tutorial purgatory.
Right. The cycle has to be learn something, then immediately practice it, and then try to build something small with it. Learn, practice, build. Spend like 30 to 60 minutes a day just on logic problems. Use sites like HackerRank or the easy problems on LeetCode.
And what about the mindset? Because hitting errors can be so frustrating.
You have to change your relationship with errors. An error message isn't a sign you failed. It's proof that you're learning. Don't just memorize syntax. Learn to love the process of debugging. That's where the real learning happens. Be patient with yourself.
So the big takeaway here is pretty clear. If you master the core logic, variables, conditionals, loops, functions first.
Then the language itself becomes easy.
Right. The syntax for Python or Java just becomes a minor detail. You've already built the muscle. The languages are just different bicycles you can hop on.
Exactly. So we've talked about how to store data and how to make decisions with it. But real programs deal with huge amounts of data. And that leads to a whole new question, which we can maybe tackle next time.
What's that?
We know what data is, but how do you organize it? How do
Yeah.
you sort it, search it, and access it efficiently when you're dealing with millions of items? That's the next level. Because strong basics today, well, they lead to advanced skills tomorrow.